Hey guys, welcome back. This is Professor Hank, and in this video I'm going to talk to you about random access in your C++ files. Okay, so let's begin. Right, so what's random access? What's sequential access? Okay, there's a couple different ways that you can work with files. Right, the first way, maybe the easiest way, is sequential access. And with sequential access, if you open up a file for reading, you start reading at the very beginning of the file, right? And so every time you do a read operation, you advance in the file, okay? And this can work for simple situations, fine. But if you wanted to read, say, the 20th line in a file, with sequential access, this means you have to read the first 19 lines of the file before you get to that 20th line that you're actually interested in, right? And maybe you just have to chuck the previous 19 lines. That's sequential access. It's kind of like if you've ever listened to music on a cassette tape, right? If you know what those are, you have to listen, if you want to listen to the 5th song on the tape, you got to listen to the first 4 songs, right, before you get to the 5th song. Or you got to fast forward through the first 4 songs until you get to that 5th song that you actually are interested in listening to, right? So sequential access is having to listen to those first 4 songs before you get to the 5th song. Random access is fast forwarding to the 5th song, right, and then just listening to it straight away. So we can do something similar with files in C++. We can fast forward. We don't have to listen to the first 4 songs. So rather than read those first 19 lines of the file, you can just skip right over them and go to the 20th line in the file, right? So that's random access. Okay, so to be able to utilize this, we also have to understand, or maybe to make it easier to utilize, you have to understand that files are basically just big arrays. Okay, so you got a file that's 100 bytes long. Each one of those bytes corresponds to like an element array. So the first byte is 0, the 0th byte, just like the first element is the 0th element. The second byte is the 1th byte, just like in the array, the second element is the 1th, right, and so on. So the first 3 bytes in a file are byte 0, byte 1, byte 2. Okay, that'll help us in navigating around when we're doing our random access. Okay, and another thing that we have to understand is this idea of file position pointers. Okay, and as you're reading through a file, okay, these position pointers are advancing. So when you first open up a file for reading, the file position pointer is at the very beginning. It's at byte 0, okay? And so when you do a read operation, you start reading all the bytes from byte 0, okay? And let's say that you read 3 bytes. Well, you would move from byte 0 into, 3 bytes within the file, right? So you'd advance to that 4th byte because you've read the first 3. The file position pointer moves, okay? And if you open a file for appending, right, so that way you preserve the contents of the file, well, all you're doing is opening the file with that file position pointer all the way at the end of the file. So that way the next write that you do is at the end of the file. Okay, so you've got these file position pointers, and so when you open a file for writing, the pointer is advancing whenever you do a write operation. When you open a file for reading, the pointer is advancing whenever you do a read operation. Okay, so now there's 2 different ways that you can open a file, right? You can open it up for reading, or you can open it up for writing. Now, for doing random access, we're going to introduce these methods called seekg and seekp. Okay, seekg is used when you've opened a file for reading, and so it's easy to remember if you think of it as seek get, right, as get, G for get, because you're going to get something from the file. You're opening it for reading. You can remember seekp because you've opened the file for writing. You're putting something into the file, so you can think of it as seek get, seek put. Okay, and in addition to these guys, these are going to be what we use to move that position pointer around. Okay. In addition to those, you've got tellg and tellp. So tellg is what you use when you've opened the file for reading, tellp for writing. And what this does is this returns the byte position of where the pointer is at that moment in time. Okay, there's a fourth thing here that we're going to need to know about, and that's this idea of offsets. Okay, so offsets are just a position within something. Okay, so there's three offsets that we identify or that we use when working with files. Right, there's ios_beg, there's ios_end, and there's ios_cur. Okay, so ios_beg is the offset that is the beginning of the file, beg for beginning. Okay, ios_end is the offset for the end of the file, and then ios_cur is the offset for wherever the file position pointer is currently. Okay, so when you want to fast forward, you have to specify how many bytes forward you want to go. You want to move that file position pointer, but also in relation to what? In relation to which offset. So if you want to move forward 5 bytes, well, 5 bytes from where? Well, you could say I want to move 5 bytes forward from the beginning of the file. Okay, or 5 bytes forward from wherever the file position pointer is right now. Or I want to move back 3 bytes from the end of the file. And so in this way, we can move the file position pointer around within the file. And wherever the file position pointer currently is, that's where our next operation is going to execute from. So whether it's a read or whether it's a write. Okay, so that's the basic theory behind it. It probably sounds more complicated than it is. So let's take a look at a coding example so you can see this all right, so I got me some Visual Studio open, ready to go, prepped and fired up, ready to go. So in comments here, what I did is I put a string A through Z, okay, and I'm going to write this to a file, okay, and these numbers here, you're looking at that going, what the heck are these? Okay, so these are going to correspond to byte positions within the file. So, if the file is a giant array, well then A would be at the 0th element, B would be at the 1th element, C would be at the 2th element, and so on. And so, since this is a file, A is at the 0th byte, B is at the 1th byte, C is at the 2th byte. Right now you're looking at the 1s and the 2s up here and you're like, well, what's that all about? Well, this is 10. I just kind of wrote it vertically instead of horizontally. So K is at the 10th position, L is at the 11th position, M's at the 12th position, and so on. U's at the 20th, B's at the 21st. Okay, so that'll help us to refer back to, the characters in the file. Okay, so I'm going to be referring back to this stuff multiple times, I think. So anyway, let's create a file, and this fast forwarding, this rewinding, this random access, this works for text files or for binary files. Okay. I'm just going to work with text files in this example, just because I think it'll be a little bit easier to see what's going on. But with binary files, it works the same. Okay. Okay. Anyway, so create an fstream object, and I'm going to open it, and I'm going to create a file called file, and I'm going to open this for writing. So I'm going to start off by just dumping, A through Z into a text file. Okay. So if F is open. Always want to verify that the file is actually open before you interact with it. Then what I'm going to do is I'm going to write to that file this string, right? These characters, okay? A through Z. Okay. I'm going to create that file so that way I can reopen it, and then we'll do some random access. Okay. And then we'll close the file. Okay. Otherwise, we'll print out an error message. Okay. So let's go ahead and make sure that our file got created. We'll just run this. Shouldn't see error. No syntax errors, no error message. Cool. So that means that my text file containing A through Z was successfully created. So now let's do this. Okay, let's do some random access. Let's open the file again. Okay, this time we'll open it for reading, so ios_in. Okay, and what I'll do is instead of reading the entire file, I'll fast forward to, I don't know, say the G character, right? I'll fast forward to the 6th byte here, which is actually the 7th because we start counting at 0. And I'll just read that one character, and then print it on the screen, rather than having to read A and chuck it B and chuck it C and chuck it D and chuck it E and chuck it F and chuck it G and print it. I'll just fast forward to G, read it, and print it, right? So sequential access would have had me read every single byte until I got to G. But with random access, I'll just fast forward, like I'm skipping past all the songs on the cassette. Okay, and then I'll read that one byte and print it out. Okay, I'll sing to you while I'm doing this. Blah, 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 blah. You ever just get relaxed when you're writing code, right? I mean, when you've finally gotten kind of to a place where you kind of can code without it just being the most frustrating thing in the world, and so you're just like, just coding, and it's relaxing, and you're in a Zen moment. I love that feeling. But anyway, so we're going to use seekg to make this thing happen. Okay, so seekg, because I'm opening it for reading. Okay, and I have to specify how many bytes I want to move into the file. Where do I want to go? So I want to get the G, right? So I'm going to specify that I want to move 6 bytes into the file, because we started at 0, right? So we want to go in 6. So 1, 2, 3, 4, 5, 6. Okay. So when I do that, I'm going to say 6 bytes, and seekg likes for the integer that it's passed as its first argument to be cast as a long integer, right? So that's why I'm putting the L there. And let's see what else I want to do. I want to say from the beginning. Okay, so I have to specify my offset and how many bytes into the file I want to move. So that's my first offset, and it's supposed to be beg, not end. I don't know what happened there. Did I just not think? I don't know. Whatever. I want to go 6 bytes from the beginning. Okay, now once I've done that, that file pointer is going to be pointing, that file position pointer, it's going to be right there. Okay, so the next read operation that I do is going to occur from that position. Okay, so I'll create a character variable, and I'll read into that. So I'll just say fget c. Okay, and then once I've done that, I'll just print it out, just so you can see what we got. Okay, so let's compile it and run it. And so there's the G, right? So I was able to skip past, the A, B, C, D, E, F, G, or the A through F, and then I was able to read the G. Okay, now when I did that read, the file pointer did advance, right? So after that read, the file pointer is now at H, right? So if I was to do another get, right, and then print it out, I should see H the next time, right? Because whenever you do a read, you advance that pointer. Okay, so there you go. So that's fast forwarding. Now what if, right? So as soon as I did that, then that file position pointer went to the next position in the array, right, or in the file, right? So what if I wanted to go back and I wanted to get the E, right? Well, what I got to do is I got to rewind. Okay, so what I could do is I can say f.seekg, and I want to go backwards. I want to go backwards a certain number of bytes, but not from the beginning, right? Because if I went backwards from the beginning, I'd be going to the beginning in front of the file, right? I'd be going out of bounds. So instead, I want to go 6 bytes back from where I just came from, right? For where I am. So 6 bytes back from the current position. That's the current offset, right? So I want to go back, not 6 bytes. I just want to go back to, I want to go back and get the C, right? So that would mean that I have to go back, if I'm at I right now, that means I'd have to go back 1, 2, 3, 4, 5, yeah, 6. It looks like 6. So let's see, maybe my math's off, okay? So I want to go back 6, so you put -6 to go backwards. So I'm going 6 bytes back from my current position. And then I'll do my get from there, and then I'll see out my C, right? So let's see if I did my math right. Right, yeah, so there's the C, okay? So I did do it right, cool. So I went back 1, 2, 3, 4, 5, 6, and then I did my get C, read the C, and then the file position pointer ended up pointing at D, okay? So that's how iOS beg and iOS cur work. Now, what if I wanted to get a hold of the X? Okay, one thing that I could do is I could do my seek again, and I could go and use the offset for the end of the file, right? So if I do that, that's going to put my file pointer, my position pointer, at the end, right? So what I'll need to do is I'll need to go back 1, 2, 3, right? So I'll need to rewind 3 bytes from the end, right? And then I'll do my, if I do my math right, you know, we'll check me, maybe I'm off by 1. And then we'll go ahead and do our read, and then we'll print out what we read. Okay, so let's see if I am off by 1 or if I got it right. So X, right? Isn't that what I said I wanted? I think I said I wanted X. So we went to the end, right? And then we moved the get pointer back 3 positions. 1, 2, 3. Then I did my get, read the X, and that's what I counted, right? And then that left the position pointer sitting at the Y. Okay, so that's how you can do random access when you're reading, okay? Now, what about if you want to write? So let's say that I don't like that G in the file, right? And I want to change it. Okay, so what I can do is, let me fold this so it gets out of the way. What I could do is I can open the file for writing, okay? And, you know, maybe I'll just comment out this extra stuff just so it's out of the way. Just in case I want it later. So if I want to get, I want to change the G, right? That's what I said I wanted to do. So let's open the file again for writing this time. Okay, for writing, and we'll check to make sure it's open. I always want to do that. Okay, and I'll print an error message if it failed to open. Okay, and so what I've got to do is I got to fast forward to the G, right? So since this is for writing, I have to use seekp. So I'll do f.seekp, and I want to go 6 bytes in from the beginning. Okay, so when I first open up the file position pointer, is going to be at the very beginning, right? So I want to go in 6. 1, 2, 3, 4, 5, 6. All right, I want to go right to there. Okay, because I want to change the G. Okay, and then what I'll do is, what should I change it to? Maybe I wanted it to be uppercase. So then I'll use the put function, and I'll make it G. Okay, and then we'll close the file. Okay, so I'm go ahead and run that, just make sure we don't have any errors. Okay, fine, the file opened. So that should have replaced that with uppercase G. That would have advanced the position pointer there. So how am I going to tell if it worked? Well, I could open it up with a notepad or something like that, but I'll do it programmatically. So let's go down here, and we'll reopen it. Okay, this time for reading. Okay, and if it's open, do a shortcut. You can just say FF. Then what? Then we'll go ahead and we'll fast forward and check our work. Right. So now I'm doing it for reading, so I need the seekg method, and so I'm going to go in 6 bytes again from the beginning. Then I'll do my read, get C, and then I'll print it out. Okay, so if I did all my math right, that's my biggest worry, is that I always having off by one error when I'm trying to do this. You know, I go one too many bytes in, or one too few bytes in, or something like that. And see if you struggle with something like that too. If you do, you know, maybe leave a comment. You know, maybe you've done that before, and you want to laugh at me too, or laugh with me, preferably. You know, leave a comment, share your stories. But so let's see if it did it. Let's see if we have success. And it looks like we do, right? So I was able to change that one lowercase g to uppercase G. Okay, so success. All right, so one more thing I want to show you. I want to show you the tell, right? So I'll comment this stuff out to get it out of here. I want to show you the tell. Okay, so we'll get all this stuff out, fold it out of the way. Boop, boop. Okay, so how big's the file? This will be a little hacky kind of thing that you can do. Now, the tellg or the tellp functions, okay, what they do is they tell you the byte position of wherever the file pointer is at, the file position pointer is at, right? So one way that you could programmatically tell how big the file is you could open the file either for reading or for writing, and then just, well, it should be for reading, right? Because if you open it for writing, and you just do iOS out, you're going to overwrite the contents of your file, right? Because that's the default behavior. So you'd have to open it for appending if you're going to do write, or you could just do it for reading to be on the safe side. So I'll open it for reading, right? Because if you open it for reading, you're not going to truncate your file. So I'll open it for reading, in which case I'd have to use seekg and tellg. So if we successfully opened, else error, right? Print out an error if we failed to open. So what am I going to do? I'm just going to go to the very end of the file. So we'll say f.seekg, and we'll go 0 bytes from the end of the file, and then I'll create a variable called size, and I'll use f.tellg to return the byte position within the file, which is going to correspond to how many bytes there are in the file, and then I'll see out size. Okay, and then we'll close the file. All right, so that's going to fast forward the pointer all the way to the end, right? To the byte position at the end, and then that's going to return, you know, how big the file is. Okay, so let's go ahead and run it, or it's going to display it. So 26. Okay, 26 characters, 26 bytes, because I moved the file position pointer to the very end, right? And when I call tellg, that tells me that it's at the 26th byte of the file. Now you might look at this and say, well, what's going on? You know, where's the 26? Okay, well, pro tip here, you know, there's 26 characters, but you start off at the 0th byte, right? When I did the write, or when I did the seek, where did it go, right? Well, there's a special character called the end of file character that gets added to files, so that way the operating system knows where the end of the file is, right? And so that's really the byte position, is at that last character. Okay, it's at that implicitly added end of file character. It's kind of like with C strings, how they implicitly add the null terminator. Same kind of a deal. Okay, but anyway, so that's everything that I wanted to show you. So what did we go through in this video? You know, random access. Talked about the differences between random access, sequential access, and also talked to you about you know, the different methods: seekg, seekp, tellg, tellp for random access, and talked about that file position pointer. And which one of these methods you use is going to depend on whether you opened it for reading or for writing, right? So if you open the file for reading, it's seekg, tellg. If you open it for, if you open it for reading, it's seekg, tellg. If you open it for writing, it's seekp or tellp. Okay, yeah, so I think that's everything. Thanks for watching. We'll see you next time. Okay, so that's going to bring this video to a close. If you felt that the video was useful, please consider giving the video a thumbs up. And if you thought that the video sucked, well, then you've got that thumbs down button as an option as well. If you'd like to see more videos, if you're interested in more content from the channel, feel free to hit that subscribe button. And as usual, if you're a student of mine and you have further questions, feel free to drop me an email or to stop by my office hours. Okay, thanks for watching, and we'll see you next time.